Hi, so this is going to be a video about how to solve quadratics, primarily when they have two x's. I made this giant worksheet with only one x and then some imaginary numbers as well. So if you feel like the video isn't for you, I'm going to make three separate videos, one for operations, one for 1x, and one for 2x's. So find the video that meets your needs. Right now I'm going to do the one with 2x's. So before I do anything, whenever I see a problem that has two x's in it, I always need to make sure that I'm setting it equal to 0. So 2x's implies that the equation needs to equal to 0. So if that isn't the case, I have to fix that first. So I see this problem that's got two x's in it, and I'm thinking, okay, I know what to do here. It's a box problem, my area model, but I have to make sure that it equals 0 first. So I'm going to take away 24 from both sides. Naturally, when I take away 24 from this side, it leaves me 0. And there are no like terms to combine there. So I just basically have a negative 24 at the back. So now what I'm going to do is I'm going to create an area model, which basically helps me convert from inside the box to outside the box. The first term always goes in this box, and the last term always goes in this box. So that's the easy part. And then it's sort of a puzzle to figure out, once I fit that in, how do I get the area to match the original problem, and also switch from the inside areas where we add them all up to the outside areas where we multiply them. So the key here is to put this first term here, that last term here, and fill in the outsides. X times x gives us x squared. And now I'm looking for two numbers that multiply to negative 24. So I'm going to try 12 and negative 2. So if I put those numbers here, I'm going to get a negative 2 with the x, because I'm multiplying this times this. Unfortunately, this times this, or this segment and this segment are the same. So if this is x, then this is x. So negative 2x gives me that. To get this area, I'm multiplying this, which is the same as that, which is again x. So 12 times x gives me 12x. And now if I add these insides up, I want them to be this middle term. And if you notice, 12x's, oops, I forgot an x there. 12x minus 2x is 10x, which is what I don't have here. So something happened where I need to kind of reverse what my decisions were, because it ended up not being what I wanted. So what that basically means is I think I chose the wrong numbers here and here. So I'm going to try to come up with another combination that gives me 24. And I think 6 and 4 will give me 24, but one of them needs to be negative, so I'm going to choose the -6. That means negative 6x goes here, 4x goes here. And if I add these together, negative 6x plus 4x does give me negative 2x. So I can switch from adding the insides, which gave me the original problem, to multiplying the outsides. That gives me x. That's a positive 4, so plus 4. And x with a -6, again equal to 0, because I'm just switching the part of the box, and so it's the equivalent problem. And now I can split and solve, set each parenthesis equal to 0. Subtract 4 in this case, giving me negative 4. Add 6 in this case to give me x equals 6. So again, two x's should lead me to a nice box problem, and then I can switch from the outsides to the insides. Oops, that's not right. From the insides to the outsides. So let's see a couple more different versions of this problem. This is the same kind of thing. I see two x's. I first have to verify that it equals 0. I'm glad that it does. And then I just move straight to the box. Once that criteria has been made, first term goes in the first part of the box. 8 goes in the corner. And now I need two things to multiply to x squared. So obviously that's x next, just like in the last problem, but I'm missing a 3 somewhere. So I'm going to put an x on the side. And again, now I just need two numbers that multiply to 8. And so what am I thinking? I wonder if 4 and 2 will work. So 4 times 2 gives me 8. That'll give me 12x. That'll give me 2x. That gives me 14x. That doesn't quite work. So I can switch the position of the 4 and the 2. Maybe a 4 and a 2 like this. So this gives me 6x. And again, that came from 2 times 3 from here with the x, so 6x. This is 4 and x, so that gives me 4x. And thankfully, if I add the insides up, 6x and 4x together does give me 10x. So now I can switch from the inside of the box to the outside. That's a positive 2. Set each equal to 0, so split and solve. And then I'll just finish the problem right here. Divide both sides by 3. There's our first answer. This one is a little easier. Set this one equal to 0 and do the inverse. And there's your second answer. So not much different to this problem except that we had to put an extra number here, but it didn't change our strategy. We still put the first term here, the last term here. X is multiply to get x squared. Sometimes we have an extra number on front, sometimes we don't. And then we try to find the dimensions that if we multiply these together, we get this number. That if we multiply the rest of these, that the inside of the box matches the original. 3x squared is this, 8 is this. These two look the same, so we add them up, giving me this. And so if the inside matches the original problem, the outside must be the modified version, and then it switches to intercept form, so I can just split and solve those easily. Okay, here's something that's very similar. 2 x's. I stop to make sure it equals 0, and it does. I've got 2 x's, 2 places where x can be. And so now I'll draw the box as usual. But again, put a 3x here. That's no big deal. And remember, the number that goes here is the plain number. So this is with an x squared. This is with an x. So there's no number here that's without an x like there was here in -24 or +8 in this case. So since there's no number in the back, that's a 0. So I'm going to put a 0 here. So I'm going to just put 3x and x here because, again, x squared will give me x and x. I'm missing a 3 somewhere, so I'm just going to place it here. Now here's where things get interesting. I need something that multiplies to 0, and there's lots of things that multiply 0. 1 times 0, 2 times 0, 3 times 0. So I can put anything I want. But I've got a 12x here, and I'm thinking, I wonder if I put a 3 here, if it makes sense if I put a 4 here. Because if I put a 4 here, 4 times 3 gives me 12. So I'm basically trying to think, what number can I put here that automatically multiplied by this number gives me this? So since 3 times 4 is 12, I'm going to put a 4 here. And then to get the area of this, I'm multiplying 4 times 3x. If this is 3x, and this is 3x, and 4 times 3x is 12x. And this is nice because 4 times what number is 0? 0. And that puts me a 0x. And then I have nothing in the middle. Or just 12x in the middle, nothing from here. So I can switch from the insides to the outsides. As usual, when there's 2 parentheses, we can set each one equal to 0. Set this one equal to 0. Subtract 0 from both sides, which we don't actually need to do because 3x is 0. Divide both sides by 3, and you get x equals 0. So again, lots of familiarity between all 3 of these. They're just little modifications of the exact same problem, essentially. All right. Again, I see 2 x's in 2 positions, so I verify that it equals 0. Yay. I'll move to the box problem. And very quickly, we'll see that this one slightly differs than the other ones because the only combo that I can think of that multiplies to 5 as a whole number is -5 and -1 or 5 and 1. But either way, -5 and -1x or +1 and +5x give me 6x or -6x, which is not what I'm going to get here. So if the box doesn't work out, we move to the quadratic formula. It's up here listed at the, oh, just kidding. On your review sheet, it's listed. It'll be listed on the test. But in case you forgot what it was or you didn't think to memorize it, which is fine. Math isn't about memorizing equations. It's about knowing how to use things, how to figure out problems in different ways. And the quadratic formula is just one of those ways that we use in case we have a problem that we can't fix. So the way that we use the quadratic formula is we identify what A, B, and C are. So this monstrosity here is the quadratic formula. And remember, all the letters A, B, and C are going to be replaced with letters. So A, B, and C are going to turn out to be numbers. So A is the number in front of x squared. So the number that's right here is 1. B is the number that's in front of x. So here's x. Look at the number in front, that's -3. And C is the number that's all alone. That's a +5. And when I say all alone, I mean without any x's. So A, B, C. Now all we have to do in this formula is literally follow the instructions. This says take the opposite of B. So my B value is -3. The opposite of that is +3. And then every time I make a substitution, I'm going to put it in parentheses. So the only one I don't do a parenthesis with is here because it's already by itself. So now B, if you look at B, it's -3. Tiny 2 on the outside. So B squared minus 4A, replace A with 1. C, replace C with 5. All over 2A. And all I'm focusing on now is, now that all my letters have been replaced with numbers, is to simplify this craziness. One number on the outside, one number downstairs, and one number underneath the radical symbol. So 3 is already alone, which is nice. 2 times 1 is 2. That's nice as well. And now -3 squared is 9. 4 times 1 times 5 is 20. So 9 minus 20 is -11. But if you don't believe me, we can go to Desmos. And so we'll do -3 squared minus 4 times A, which was 1, and C, which was 5. So this was our equation. So when you type that in there, you get -3 parentheses squared minus 4AC after we replace A and C with 1 and 5, and you get -11. So I'll put -1 under the house here. And again, I'm okay with that as an answer. What I'm not okay, though, with is having an imaginary number, which is the square root of a negative. So all we have to do is remove the minus sign and turn it imaginary, because the square root of -11 is not real. If I go to Desmos and ask it to do the square root of -11, it's undefined. It's not real. It's imaginary. So that's why I switched from a -11 to a +11 with this imaginary symbol. And that's it. So we know how to solve all problems with 2 x's in it. They're almost all the same thing, but there's a little variety. If, sometimes we have an x squared with a number in front. Sometimes we have an x squared without a number in the back. But all of these are box problems, and it just takes a little bit of time to work through them. But essentially all we're doing is skipping from the inside of the box to the outside. I wish I could do this box problem as well, and I can. It's just the numbers are terrible, and in this case they're actually imaginary, so we need a backup plan for the box. If the area model doesn't work for you, we switch to the quadratic formula, and that's pretty much it. Hope that helps.